USGS scientists studying Mount Rainier have long recognized that the greatest hazard posed by the volcano is from landslides that begin high on its slopes and transform into mudflows, or lahars, that travel great distances down river valleys. Lahars are rapidly moving flows of water, mud, and rock. They can move almost as fluidly as water, yet be as dense as wet concrete. Lahars can bury or carry away nearly everything in their paths and leave behind a layer of hard rocky sediment. Large lahars commonly accompany volcanic eruptions, but they can also develop from landslides that occur without eruptive activity or any warning, making it very important that people understand lahar behavior and hazards. USGS scientists and mathematicians teamed up to develop state-of-the-art computer simulations that show what happens when large landslides on Mount Rainier's western flank transform into lahars and descend into the Puyallup and Nisqually River valleys. The simulations show where and how far the lahars can go, when they arrive, and how deep the lahar would be. This simulation starts with a landslide in the Sunset Amphitheater area. The timer shows elapsed time after the landslide begins. The colors represent depths. Light yellow is less than 3 feet, dark red is more than 150 feet. In this scenario, 260 million cubic meters of rock and ice, a volume similar in size to the Electron Mudflow that occurred at Mount Rainier about 500 years ago, slides off the volcano. If the material is dense, hard rock, the landslide stabilizes before flowing very far. This is the low mobility scenario, and it never reaches communities downstream. But if the rock is weak and has a lot of clay, the landslide will transform into a highly mobile, swift-moving lahar. Part of the lahar flows south and enters the Nisqually River Valley, but most of it moves into the Puyallup River drainage. The lahar reaches the town of Ording in about 50 minutes. The lahar slows and spreads across the wide valley between the Puyallup and Carbon rivers. The shades of orange represent depths of 6 to 16 feet. Along the river corridors, it is much deeper. After passing through Ording, the lahar continues to the Sumner and Puyallup lowlands, arriving in 3 to 4 hours after the landslide begins. The lahar will slow and come to rest in 4 to 5 hours, but the deposit may remain liquefied for many more hours and flooding may occur downstream. This next simulation starts with the collapse of the steep cliffs of the Tahoma Glacier Headwall. The timer shows elapsed time after the landslide begins. The colors represent depths. Light yellow is less than 3 feet, dark red is more than 150 feet. In this scenario, 260 million cubic meters of rock and ice slides off the volcano. If it is mainly dense, hard rock, the landslide stabilizes before flowing very far. This is the low mobility scenario that never reaches communities downstream. But if the rock is rich in clay, the landslide will transform into a highly mobile, swift-moving lahar. The lahar that travels down the Puyallup River drainage will arrive in Ording in a little over 60 minutes. There, it slows and spreads out across the wide valley. After passing through Ording, the lahar continues to the Sumner and Puyallup lowlands. The lahar that travels down the Nisqually River drainage will arrive at the national park boundary in about 5 minutes and the community of Ashford in about 15 minutes. The lahar reaches the Alder Lake Reservoir in about 50 minutes. The lahar begins filling the upper end of Alder Lake. The sediment-rich lahar, which is the brown color, mixes with lake water, which is blue. The lahar doesn't generate a substantial wave. Instead, over the next 50 minutes, the lake level slowly rises. About an hour and a half after the landslide begins, water starts overtopping the Alder Lake Dam. The computer simulation ends 2 hours after the landslide begins and does not address what happens to the dam when water begins flowing over it or what might occur downstream of the dam. We do not know when the next large lahar at Mount Rainier will occur or how big it will be. These computer simulations provide estimated lahar travel times and depths, so emergency officials and communities in lahar hazard zones can continue to take the steps necessary to prepare for a future lahar by developing alert systems and evacuation routes that lead away from valley floors. You can do more by following 3 steps: learn, inquire, plan. First, learn about the volcanoes and hazards that could affect you. Second, talk to local officials about their plans to handle a volcano emergency. Third, develop a family preparedness and communications plan and a kit with emergency provisions. Know how to access information during an emergency and be ready to act. If you are at risk from lahars and are aware that one is in progress, move rapidly off the valley floor.